I'm James Leach. This is a practice session recording of a presentation I'm giving to the Monterey Audubon Society on November 9th, 2021. The Climate Reality Project was founded by Al Gore following his 2006 movie, An Inconvenient Truth. So why am I interested in climate change? I didn't vote for Al Gore in 2000. As someone whose entire career was in the automotive industry and who also loves powerful automobiles, just watching the movie wasn't enough to convince me to give up my fossil fuels. So I began reading about it. It was gradual at first, and over time it turned into something of an obsession, really. I read dozens of books, articles, and scientific research reports, such as the UN's IPCC assessment, and even some works by people claiming it was all a hoax. Long before my retirement in 2015, I had concluded that Al was right all along and that we needed to act, and soon. It occurred to me that in all of my research about climate change, I hadn't encountered any books that I thought many ordinary people would read. To be clear, there were many excellent works, but hardly anyone reads them. I decided to try to fix that. The Sustainable Way is a plain-spoken 50-page booklet. It's a comprehensive source of information covering the science, economics, politics, and technology of global warming and renewable energy. And it's easy to find. And here in Pacific Grove, it's in our local library. I first learned of Audubon's climate campaign when this special issue of Audubon magazine titled Birds and Climate Change arrived in our mailbox in the fall of 2014. The report names 314 birds as on the brink. That number is now up to 389 species. Their website is a great source of information about how human activity is threatening the natural world and what we must do to address the crisis. When this photo was taken on the last Apollo mission in 1972, most people were unaware that we were changing the climate. We now know those changes are threatening our very existence. Let's start with some good news. We receive enough solar energy every hour to satisfy all the world's needs for an entire year. Now, the heat from the Earth constantly radiates towards outer space. Some of the gases in the atmosphere have physical qualities that interfere with the passage of heat radiating towards outer space. And this warms the planet, keeps us warm. This greenhouse effect is a good thing. Without it, the Earth would be a frozen planet. Prior to the Industrial Revolution, which began in the mid-1800s, the level of greenhouse gases in our atmosphere had remained relatively stable for all of human evolution and the development of human cultures. Since then, we've been adding greenhouse gases to the atmosphere, and it's warming the planet. Let's talk about these greenhouse gases. Just what are they? Carbon dioxide is an odorless and invisible gas that accounts for about 2/3 of the greenhouse effect. We have been increasing the level of CO2 in the atmosphere as we have burned ancient fossil fuels containing carbon, such as coal, liquid petroleum, and methane. At the same time, we have been reducing the planet's capacity to remove CO2 from the atmosphere through the natural carbon cycle. This is due to deforestation and destructive agricultural practices, and also development of housing, industry, mineral extraction, and of course transportation. The level of CO2 in the atmosphere is now at 420 parts per million, which is a 50% increase from pre-industrial times. And it's accelerating as global population grows and more nations become industrialized. One half of the increase since the Industrial Revolution has occurred in the past 40 years alone. Methane, the main ingredient in natural gas, is a potential greenhouse gas responsible for 17% of the greenhouse effect. Ancient fossil methane escapes into the atmosphere during fossil fuel extraction and natural gas distribution and use. Methane from animal agriculture and decomposing organic matter also adds to our methane emissions. The amount of methane in the atmosphere is now 2.5 times, a 250% increase from what it was in 1850. Synthetic gases are responsible for 12% of the greenhouse effect. These man-made gases enter the atmosphere primarily from the servicing and disposal of equipment that use refrigerants, such as refrigerators, freezers, air conditioners, and heat pumps. Some are also released in the atmosphere through manufacturing processes such as semiconductor manufacturing. They, of course, did not exist in 1850. Nitrous oxide is responsible for most of the remaining greenhouse effect. The primary source of nitrous oxide is the excessive release of nitrates from synthetic fertilizers and animal waste. Nitrates that are not taken up by plants are converted through natural processes into nitrous oxide. And the other significant source of N2O is from the combustion of fossil fuels. We now have a 20% increase from what we had in 1850. So there they are, all substantially increased from what we had at the beginning of the Industrial Revolution. This illustration shows many of the sources of our emissions that cause our global warming. We humans aren't very good at recognizing things that we can't easily detect with our senses. All of the emissions described in this slide are beyond our perception, out of sight, out of mind. If a person isn't exposed to or receptive to science, it isn't surprising that they would be skeptical of global warming. We only have 3 questions that we have to ask. Must we change? Can we change? And will we change? Here you see the representation of observed temperatures between 1880 and 2020, global surface temperature, and the departure from average. As you can see, the general trend is unmistakably clear. Global surface temperatures are increasing. If there's any doubt about a warming climate, just consider that the 20 hottest years on record have occurred in the last 20 years. You may have heard that on our present course, we can expect a global average temperature increase of from 2 to 4 degrees Celsius this century. Sometimes we hear people say that a few degrees warming doesn't sound so bad. Well, first recognize that in the temperature scale we all understand, which is Fahrenheit, this equates to a 3.6 to 7.2 degree Fahrenheit increase. To solve for a Fahrenheit change from a Celsius change, you multiply it by 1.8. And if you can't remember that number, just double it. That'll be close enough. It is also important to realize that when we hear about projections of global average surface temperature increases, they are based on temperatures from all over the planet, including 70% of the surface, which is ocean. And because ocean locations benefit from water circulation and evaporation that both carry heat away, they will not experience as much temperature change as the extremes of locations inland. Locations well inland with an abundance of materials that hold heat, such as concrete, asphalt, and rock, and that have little water evaporation, will experience average temperature increases that are significantly higher than the predicted global average. When atmospheric pressure rises, the air warms even more. Add valleys and mountain ranges or weather systems that hold this superheated air in place, and temperatures can soar and linger for days. That's exactly what happened in Los Angeles on September 6, 2020, with a temperature of 121 degrees Fahrenheit. Here we see Northern Hemisphere summer temperatures from the period 1951 to 1980. Now, as we move forward on the next slide, we'll hold that baseline steady so you can see what's happening to our temperature distribution. Jumping forward a decade, you can see that we now have far fewer days that were considered, where the temperatures were considered cooler than average and average than we used to have, and far more days that are warmer than average or extremely hot. Moving another decade, you can see it's much worse. Here's an article out of the Sacramento Bee. It references research from Scripps Institution, San Diego, where climate modeling shows that on our present course of greenhouse gas emissions, Sacramento will have more than 40 days per year over 104 degrees Fahrenheit, beginning in the second half of the century. To have a sense of comparison, Tucson, Arizona currently only has 30 days per year over 104 degrees Fahrenheit. Just imagine what such conditions will mean to humans and wildlife in our Central Valley and in the Sierra and coastal mountain ranges. We can expect the same conditions in our local inland locations. Who suffers? Well, the truth is, we all suffer, some much more than others. Climate is really a global engine for redistributing heat from the equator to the poles. And it does so with wind currents, ocean currents, and storm systems. The pattern of these winds and ocean currents is defined by the difference between the temperature at the pole and the temperature at the equator. As we have been increasing global temperatures, what we're finding is that a 1 degree Celsius increase at the equator results in a 3-time increase in the temperature at the poles. So when that differential changes that significantly, all of the long existing patterns are subject to change, and we're seeing them pushed out of their normal traditional patterns. Now, one of the effects of The warming at the poles is, of course, the melting of ice and snow. The loss of that those reflective surfaces causes additional warming because it reduces the reflection of light energy back into outer space. As soon as this land is exposed, it holds more heat. Now, the scariest part of this is the melting of permafrost soils, which is causing enormous amounts of methane and CO2 to be released. These gases are trapped in the ice crystals from the permafrost soils, and as they melt, it's released into the atmosphere. This is also devastating to wildlife. Countless bird species nest in these areas. There's also lots of mammals whose migration is affected by what was historically frozen land and now it's boggy. The greenhouse gas emissions from permafrost soils are now reaching the levels of the entire emissions from countries such as Japan and Russia. Let's take a look at the South Pole. Here we see ice loss accelerating rapidly. Global sea level is already 9 inches higher than it was in the late 1880s. The rate of rise is increasing, with 3 inches occurring during the past 30 years. And even if we take very aggressive steps to bring down our greenhouse gas emissions, we're locked in for at least another 10 inches by 2100. And on our present course of high greenhouse gas emissions, sea level rise by the end of the century will be measured in feet rather than inches. More than 1 billion people live very close to sea level and will be displaced as oceans rise. Here we see how the rising sea is affecting our coastlines in North America. You'll notice that the exponential increasing flooding is occurring mostly on the eastern seaboard in the Gulf. This is, of course, because of the gradual slope of the land. To see where we're headed over a very long period of time, geologists tell us that the last time Earth's CO2 level stabilized at our present level of just around 400 parts per million was a few million years ago. And at that time, sea level was 60 feet higher than it is now. And of course, it'll take hundreds of years at this level of CO2 emissions to reach that level. But clearly, you can see the direction of our rising seas. Most of the heat that's been accumulated through global warming is absorbed into the ocean. And it's having a devastating effect on sea life. Reefs are being bleached, and of course the creatures that thrive in those locations are displaced. We're also acidifying the ocean because of the carbonic acid that forms in the atmosphere with the CO2 as it drops with precipitation. This is having a devastating effect on many of the small creatures that are at the base of the food chain. We're also seeing the expansion of dead zones in the oceans. Now, this is caused by a combination of warmer temperatures and excessive pollution, primarily from fertilizer runoff. The nitrates and the warm temperatures cause algae blooms. When the algae dies, the bacteria that thrive on the algae they consume all of the oxygen, the dissolved oxygen in the surrounding waters, leaving the oxygen level so low that fish die. So that's why they're called dead zones. They, of course, have long been occurring where rivers exit into the sea, but now we're seeing it also in open ocean areas. As much as 60% of our fish species are at risk in the balance of this century. And of course, for bird lovers, just imagine the impact this is going to have on our ocean birds. Here we see the Earth's current uninhabitable zones. Now, on our current path, these will expand significantly. Here we see by 2070, large swaths of Central America, South America, India, Africa will be considered uninhabitable. Now, this is going to affect all the people that live there. It's going to drive a lot of immigration out of these areas, untold suffering. It's also going to be very harmful to native life. A lot of creatures migrate through these areas. It's going to disrupt their life cycles. Here we have an animation that shows the expected increase in dried earth, soil moisture in North America. And as you can see, as it advances, North America is going to become much more arid. Food, of course, is tied to climate. Food production is affected by many factors, not the least of which is the lack of water and high temperatures, but also pests and other issues related to the effects of global warming and a changing climate. These staple products, or crops, they're all affected by increases in temperature. %40 of the world's population already experience water scarcity. This shows the waviness of the jet stream. It's looking at the top of the globe. And what we're seeing is that there's always been deviations in the jet stream, but they're becoming more severe and more common. So what's happening? Well, the polar vortex at both poles is driven by the temperature difference between the equator and the poles. And as that temperature decrease or difference declines, it's affecting the jet stream. It's becoming more wobbly. This is allowing cold air to sometimes move farther south than it ever has or typically does, and conversely, warm air to move farther north. And we have two good examples of this in the United States this past year. The first was the hard freeze in Texas, where extremely cold temperatures dropped down into that region and stayed there for a week. The second was the extremely hot conditions that occurred in Washington State, Oregon, and Canada. Temperatures they'd never experienced before. That heat wave was devastating to wildlife. Also cost a lot of lives, human lives, and spawned some terrible wildfires. We all remember Hurricane Katrina, devastating storm with a lot of damage. We aren't necessarily having more storms, but we're having storms that are more powerful. They pack a bigger punch. Warm air can hold a lot more water. we already are seeing a 5% more water vapor content over the oceans than we had only 30 years ago. Water content in the air drives the severity of these storms. These storms are risking a lot of our infrastructure. And here in California, we've seen all of these occur in recent times. Dams that are threatened or overrun, sewage systems that overflow, roads, bridges washed out, landslides, destruction of agriculture. Extreme weather is causing lots of damage. This information is provided to us from the reassurance industry. These are financial institutions that insure the insurance companies. Now they, of course, are very interested in risk, and so they track severe and extreme weather and catastrophes. And you can see that there's an obvious trend from 1980 through 2020. And here in the West, many of us know of people who are having a hard time finding insurance for their homes because the risk's so high, especially from wildfire. And it's expensive. $102 million spent between 2010 and 2019 on extreme weather. Tropical diseases are also on the move as their range expands because of warmer temperatures. And we're seeing insects such as mosquitoes, ticks, both of which carry diseases, expanding as well. We're also seeing severe environmental damage from beetles, for example, in our forest, where they used to die off in the winter because of the hard freeze. Well, now they're able to survive. Climate change is also increasing the risk from waterborne infectious diseases. Floods make it even worse when sewage systems become overrun. And it's also becoming an issue in agriculture to keep these bacteria from getting on our food. Let's talk about migration and immigration. This farmer lost his farm. And that drought in Syria drove 1.5 million people into their cities. And of course, there was a devastating war as a result of that friction. Now we've been seeing, immigration across Europe from the Middle East and North Africa for a long time now, and it's created a lot of tension in Europe and the European Union, a lot of political instability. And here we see a poster that was used in the Brexit campaign in the UK. And of course, the image that it's portraying is bands of immigrants marching into the UK. It isn't just happening there, though. Here in the Americas, we also have an immigration or a migration problem. And it's not a migration from Mexico into the United States. We actually have net negative immigration, where more people are moving from the United States into Mexico than the reverse. Our migration issues are from the Central America. And these are places that have been devastated by storms. They've experienced extreme droughts, very high temperatures, crop failures. These people are leaving because they're hungry. They see no future there. This problem's not getting any better. As far back as 2014, the Department of Defense recognized that climate change was a severe risk to our national security. Air pollution. Worldwide, 9 million people die prematurely from air pollution every year. And this doesn't include the terrible suffering that occurs from many diseases that don't get attributed to air pollution because their death isn't attached to it directly. Developmental disorders, early onset dementia, many cancers, even type 2 diabetes is affected by air pollution. So the price isn't just the number of deaths, but there's a lot of suffering and damage that occurs not only to people, but all the wildlife is also affected by this same pollution. %40 of the people in the U.S. live in counties that don't meet EPA air quality standards. And this is primarily from the release of air pollution from our use of fossil fuels. Here in California, we have 10 of the worst regions in the nation for fine particulate matter air pollution. All of the Central Valley, the San Francisco Bay Area, and also the greater Los Angeles basin. They're all included in that. And wherever you're burning coal, you're going to have mercury pollution. The impact of air pollution is tremendous. Of course, this doesn't express the human suffering that occurs. This is just the financial burden. Here we see tree cover loss between 2001 and 2018. Commodity-driven deforestation. You see all of the red in the Amazon. What's happening there is that they're cutting down the forests in order to provide grazing land and land for crops. The problem is the soil there is quickly depleted. And so in order to keep the economic engine running, they cut down more forests. This is having a devastating effect on wildlife, and it's also affecting the ability of the planet to sequester carbon. As these trees are cut down and these areas are cleared, carbon dioxide, or the carbon that had been stored in those places, is now released into the atmosphere as CO2. The other surprising thing about this image is if you look at the far north, we're having an awful lot of wildfires in Alaska, far northern parts of Canada, and Russia. All of this is also devastating to wildlife. They call this period we're living in the sixth great extinction. We are now in danger of losing 50% of the land-based species on Earth in this century, on our watch. This is a deeply unethical and immoral problem. We have to take responsibility for preventing this from happening. So must we change? Yes, we must change. But can we change? Here's an opinion piece out of the New York Times by Al Gore. He says the climate crisis is the battle of our time and we can win. We have the tools. Now we are building the political power. Let's talk about those tools. We have the know-how and technology to supply zero-emission energy for transportation, heating, cooling, cooking, and all of industry. We know how to do this. We have the technology, we have the know-how. We know how to transition to sustainable agriculture. We know how to detect and cap methane leaks. And we know how to capture and sequester carbon dioxide. Much of this is through natural processes, restoring land, reforestation, using sustainable agricultural practices. And we also have hard technology that can pull carbon dioxide out of areas that have a high concentration of CO2, such as in exhaust streams from combustion plants. And one of the factors that's driving the increased emissions of greenhouse gases is growth in population and industrialization. Well, we know how to curb impoverishing overpopulation growth simply by providing education. Now we know how to do all these things. There's going to be a big upfront cost. But when you consider the alternative, and on our current course of high greenhouse gas emissions, the costs we're going to incur are beyond measure. So yes, we know how to do it. The problem is we aren't deploying these solutions at a scale that is making enough of a difference. For example, global greenhouse gas emissions from electricity generation is now more than it ever has been, in spite of the fact that we have an explosion of installations of solar and wind. Problem is we're just not growing those forms of renewable energy at a rate that is able to keep up with the natural expansion of demand for electricity. Another example, here in California, our greenhouse gas emissions from on-road transportation is increasing. If you look at the last decade, the trend is upward. Well, this is in spite of the fact that we're driving far more high-mileage hybrid vehicles and plug-in vehicles than we did in the past. So what's happening? Well, urban sprawl is a big factor. In order to find affordable housing, people are moving further away from their jobs, and so they're commuting farther distances. We also have a booming economy. There's a lot of transportation going on, a lot of goods being moved around. And you may have noticed that a lot of people are driving bigger cars than they ever have before. Big SUVs, all the pickup trucks are bigger. We're just burning a lot more fuel than we did. So yes, we can change. But will we? Let's look at the enormity of the task. This pie chart shows global greenhouse gas emissions from different activities. Now up in the upper left corner, you'll see that it says 50 billion metric tons of CO2 equivalent. That's a big number. It's hard to get your head around that number. But if you compare it to the population, it's easy to relate to the fact that that's about 40 pounds per person per day. 40 pounds of CO2 released per person every day. The upper slice of the pie, where it says other energy, that relates to the exploration, extraction, and processing and distribution of fossil fuels. So about 10% of global greenhouse gas emissions occur getting fuels to us. This is before we burn the fuels. Transportation is responsible for 14% of global greenhouse gas emissions, and agriculture 24%. Now I will point out that if animal agriculture was separated out from the total agriculture category, it would be about the same size as transportation. It's 15% of our greenhouse gas emissions globally comes from animal agriculture. When I say animal agriculture, I'm talking about everything involved in raising animals, feeding them, producing the crops that they eat, providing water to them, and so forth. Now this is the global view. Let's take a look at our local situation. Each year, the California Air Resources Board publishes their California Greenhouse Gas Inventory. And here you can see on the right side that we have far less greenhouse gas emissions, of course, than what we have globally. In fact, if you do the math, the 425 million metric tons of our greenhouse gas emissions, it's about 0.85% of the global number. Less than 1% of global emissions are attributed to California. And here in California, our rate per person per day is 65 pounds per person per day. 65 pounds of CO2. Now, if you look at the rest of the United States, their number is almost double what the California number is in pounds per person per day. If you compare California to the European Union, they're about 20% less than California. Now, a couple comparisons that will help you grasp this number, this 65 pounds per person per day. Let's talk about transportation fuel. If you include the emissions from the direct emissions from burning these fuels, plus the emissions from refining and distributing the fuels so that we have them to burn, each gallon of fuel that we burn in our cars and trucks contributes about 25 pounds of CO2. So you use 2 gallons of fuel, that's 50 pounds. Another number that's easy to relate to, when you pay your utility bill, if you have gas, natural gas, you get charged by the therm. Each therm of natural gas, which is a measure of heat and volume of natural gas, releases 12 pounds of CO2. Of course, our distribution of our emissions is quite different than the global. We have much less for agriculture and considerably more for transportation. Looking at it a little closer in more detail, you can see that passenger vehicles plus heavy-duty vehicles plus the emissions from refineries, extraction of oil out of our ground, and the pipelines to move it around, nearly 1/2 of California's greenhouse emissions are from on-road transport. So if you're looking for an area to have a big impact, this is it. Here we see a global representation of emissions by country and activity. First of all, consider that if you look at the emissions of greenhouse gases that are already accumulated in the atmosphere, the United States is responsible for more than any other nation. And this is because up until recent times, we were the largest emitter, and that was primarily through the entire previous century. This chart shows annual emissions now. And as you can see, China is the biggest emitter currently, and we're not far behind. And if you look at where their emissions are occurring, they're all related to their manufacturing and industrial processes. So what's happening here? We have offshored our manufacturing to China and other countries. China has basically become the manufacturer for the entire world. So as we import goods made in other places, we're still causing greenhouse gas emissions even though they don't occur here in California. So we have to be responsible for that. There have been some studies that are based on consumption as opposed to direct measured emissions. This analysis showed that Marin County in California has consumption-based greenhouse gas emissions nearly 3 times that of measured emissions. And the overall region consumption-based greenhouse gas emissions were 35% higher than their measured emissions. So if you take that 35% number and apply it to the California 65 pounds per person per day, you increase it by 35%, we're looking more like 85 to 90 pounds of greenhouse gas emissions per person per day in California. Back to that New York Times piece. Let's look at the political power he's referring to. What it means is the United States and the world have to be mobilized. So what's in the way? Speaking very broadly, humankind is simply not yet at a point where we're taking climate action as a moral imperative. Collectively, we are saying that the continuing of our polluting ways is okay, in spite of it destroying much of the natural world and subjecting our descendants to live in a tortured world and to experience untold suffering. Now, looking in detail at what the barriers are, the first, of course, is vested interests. The obvious big players here in vested interests are the nations of the world that derive their wealth primarily from the sale of fossil fuels. Countries like Russia, Saudi Arabia, and all the OPEC countries. You also have to look at the major oil companies who have significant reserves of oil from all over the globe. They have a vested interest in keeping the oil flowing and the coal burning. And of course, these entities have the highest accumulation of wealth on the planet. And they're not setting down, ignoring the issue. They're spending a lot of money, PR campaigns and so forth, to discredit the climate movement and to continue their use of fossil fuels across the globe. It doesn't stop there, though. There are countless companies that do business with this sector. They all have a vested interest as well. Then you have the employees. Here in California, we have a lot of employees in places like Kern County and Contra Costa County, where we have a lot of oil industry, as well as Los Angeles. They have a vested interest. And the communities they live in, they have a vested interest as well. So places such as Oklahoma, West Virginia, you have a heavy concentration of people that have an economic interest in keeping the status quo. And it doesn't stop with them. All of us have some vested interest in this industry, keeping fossil fuel industry going. Sometimes it's in our portfolio for our retirement accounts, or 401ks. And we even have investments in resources that we use, appliances and vehicles that burn their fuels, and we want to get our value out of those. So the vested interest factor is a big one, standing in the way of making the necessary changes. We also have a lot of distractions. Let's face it, you've got pandemics going on, you've got kids you get to get off to school, you have careers to manage. We have a lot going on. Climate change should be at top of mind and highest priority in our scale of actions that we should be taking, but we're distracted. There's also a lot of short-term thinking. We're busy. It's a lot easier to deal with the immediate issue directly in front of you instead of thinking long-term, even a decade down the road. That's why we're seeing so few people even put money aside for retirement. But in some sectors of business, short-term thinking is actually planned into the system. A lot of corporate executives, they don't really look long-term. They're compensated based on this year's earnings, or in many cases, this quarter's stock market value. We have to change that. We've got to think long-term, because long-term is when we're going to have the greatest disaster from climate change. There's a lot of distrust of science. Some of this is attributed to the general public not being very educated on science. Scientists themselves have to take some of the responsibility here. Scientists aren't very good about communicating to the general public. They're very good, very precise at communicating amongst themselves, but they use a language and methods with statistics, for example, that the general public has a hard time identifying with. The other factor is the media. The news media thrives on creating drama, something to draw you in. And so they like controversy, because that works. They often air information about climate change denial that is not credible at all, but it does build an audience. Humans also have an inclination to externalize costs. You know, the examples that stand out, of course, are companies that used to dump their emissions or their waste products directly in streams and rivers, oceans. Well, we created regulations to prevent that, but there are still a lot of externalized costs. Talked earlier about methane being released during oil exploration. Well, in many cases, it costs more to contain that, trap it, pipe it off. And so because it's odorless and invisible, the easiest thing to do is to just let it float off in the atmosphere. And when they abandon those oil wells, they just continue to let it escape. Another big example is how we individually externalize our costs when we burn fossil fuels. Effectively, that's what we're doing. Every time we burn a gallon of gas, 25 pounds of CO2 goes off in the atmosphere, and it's called an external cost because someone else is paying the cost for that, not the user. And of course, we have a lot of resistance to and fear of change. You know, something as simple as switching from a gas range to an induction range can be a hard decision to make. There's a lot of unknowns. You've got to do some investigating. You sometimes have to run a high power 50 amp circuit to the kitchen. It's difficult. And lastly, there are lifestyles, identity, and political polarization. The lifestyles factor is easy to identify. There are many people who live a lifestyle where the use of fossil fuels is an important part of their everyday experience and their pleasure. If you know someone who's into off-road, four-wheel drive off-roading, or motorcycling, or driving hot rods, powerful cars, those people tend to be resistant to any actions that's going to restrict or make it more expensive to use fossil fuels. Then there's a political identity, or in some cases it's not political as much, it's just identity with the groups that we associate with. In some parts of the country, the biggest barrier to installing solar is the fact that it's like putting a badge on your home that says, I've changed sides. People don't want to be unaccepted in their identity group. And then, of course, the politicalization of climate change means that in many cases, if one side's for taking action on climate change, the other side's against it just because they can't do the same thing. So how do we mobilize for climate action? First of all, there are government and international policies. Investments in renewable energy and storage infrastructure. We have to make massive investments in these areas. I'm not just talking about throwing money at it. This has to be well planned and timed so that we don't have economic disruption, so that people are treated equitably. And in the end, we'll have a lower cost energy system, a more resilient energy system, and a better distribution of wealth because of the use of renewable energy. Also, incentives to reduce greenhouse gas emissions. There are many forms of these. For example, here in California, we have significant um, incentives for buying an electric vehicle. You can get more than $10,000 in many cases for buying electric vehicles. We also may need to put a price on our emissions. You have to be careful with that. You don't want to harm the people who can least afford it. That's what happened in France a few years ago when they imposed a carbon tax. They had a revolt on their hands because the people that it was affecting the most were those that had the least income. Then there are regulations. In some cases, the regulations are the best approach. Making it impossible to purchase an electric vehicle at some future date is a good way to send a signal to the market and to all the people that we need to plan on that, plan on the change. Personal actions. Sometimes people say that what they do personally doesn't make much of a difference, so why do it? The truth is, though, our examples, both good and bad, have influence. If we take no personal action, that example sends a signal to family, neighbors. Conversely, if we take action and we share our experiences, we can have an influence. You've probably heard this before. Being energy efficient is very important, and it is. And this comes in many forms. Just reducing your use of energy in your home and how you drive. Planning your trips so you have fewer trips. Buy locally. There are a lot of ways you can improve your energy efficiency. Just walking more and bicycling can make a big difference. Switch to emission-free energy. Here in California, we're fortunate that we have community choice programs where you can choose to buy renewable energy in your area. In our case, we've got Central Coast Community Power, and you can contact PG&E, our public utility, and ask them to purchase renewable energy on your behalf. In our case, we power our vehicles with that as well. And then we have to consider the global warming contribution of products we consume. We're starting to see labeling of greenhouse gas content on products. We'll probably see this first on big ticket items, automobiles in particular. Both Volkswagen and Ford have announced that they have plans to move to zero carbon manufacturing. And of course, it'll be to their advantage to publicize that. Probably the most important thing to do is to talk about it. Studies show that we aren't talking about it with our friends and neighbors. We need to. So will we change? Like it or not, change is upon us. We can continue in our current course, face untold suffering, and lost much of the natural world. Or we can become good ancestors and begin a new age of living sustainably. Join those who are using their voices, their votes, and their choices to fight the climate crisis. Because your world depends on it. Before I leave you, I wanted to give you some recommended reading. I've already mentioned my own book, and I would recommend it to anybody that you think is going to have a hard time sitting down for a long read. The Sustainable Way is the title of my book. You'll find it available on Amazon, and you can order it through any bookseller. And in many cases, it might be available in your library. Now this book by Michael Mann. First of all, anything Michael Mann writes on this subject is worth reading. This is his latest piece. Michael is the director of Earth System Science at Penn State University. He's a climatologist and geophysicist, and when if you watch the media, he is very commonly a person that gets interviewed, and so you'll recognize him when you see him. But a good piece. Here's one, Regeneration by Paul Hawken. This is currently on the bestsellers list. Mr. Hawken is an environmentalist, a very successful entrepreneur and author, and he's basically devoted his life to environmental sustainability. It's an interesting book. It describes an awful lot of natural ways that we can draw down greenhouse gas emissions. Another book by Mark Jacobson, 100% Clean Renewable Energy and Storage for Everything. Now, Mark is a world-renowned and professor of civil and environmental engineering at Stanford University. He's the director of Stanford's Atmosphere Energy Program. Now, this is a technical book, but it digs into the details of how we can make this happen, and we have the technology to do all these things, including some of the hardest things to do, like air travel, making steel, for example. And the last book, Saving Us by Katharine Hayhoe. Katharine's a unique individual. She is a climate scientist, an atmospheric scientist, and professor of political science at Texas Tech University. She's also the director of their Climate Science Center. Now, Katharine is also a evangelical Christian. And Katharine's been speaking to very conservative audiences right in the middle of the oil patch for years. And so she understands how to communicate these issues to what are difficult audiences. And she has an awful lot of good guidance in her book on that subject. She's also a very common speaker. You'll find wonderful presentations by her through Facebook and other media. Thank you very much for your time and attention.